Hi everyone, here Mr. Christopher Ody, and today we're gonna talk about normal distribution. Let's start with a little review about the standard normal curve, okay? Z-scores and things like this. Well, the normal distribution is a curve in which we can have some probabilities depending on how far a number is from its median, okay, in a set of data. So for example, if we have the averages or all the height of people in a population, we will find a mean height, right? So you can have also the standard deviations from this number, and then if I ask you what's the probability to get a man of 1 meter 85 centimeters, what's the probability to find a man like this in our population? And then you can compare to this curve, and depending on how far this number is from the mean, you can tell me, okay, Chris, is about 10% or it's about 2%. It's going to depend on the standard deviation, okay? So if you remember, we have zones, okay? The zones is separated by standard deviations. So in between the mean and the first standard deviation, we have about 34.1% of all people in our example, okay? And if we consider the range from -1 standard deviation and +1 standard deviation, so the total is going to be the sum. It's going to be 68.2. So most of people are within these two standard deviations, okay? And then, okay, we're gonna have short people here, and we're gonna have also more tall people here, but at the end, most people are going to be around the mean of numbers, okay? And we can have extreme cases, maybe people about 2 meters or more, maybe people about 1 meter and 40 centimeters. They are normal people, they are not suffering about any disease, but for any reason they are very far from the mean number of the population, okay? These guys would represent 2.1% of probability. So how can we use this standard curve to find probabilities in our example? Okay, we have to use something that we're gonna call the z-score, okay? Because it doesn't matter the numbers that you're going to fill in these spaces, alright? Okay, the median is going to be 1.77 or 1.78, the mean of height of people. Or maybe we can talk about other thing that has this behavior, like what is the thickness of, I don't know, flowers stems, okay, in a field. We can use the same example, the same curve. But I'm gonna keep going with this population, how high are the people in a population, or how tall is the people in a population. Because this is a very simple example, very easy to understand. Alright, I don't want to spend too much time with this, so let's go for this practical example. So if you have a mean of 1.77 and a standard deviation of 4 centimeters, okay? It's going to be 1.77 meters, so 0.04 centimeters is going to be our standard deviation. Alright, so the things that we need to consider are the position of these guys here. We can say that the population that is around 1.7 1.73 to 1.81 are going to represent 68.2% of people of this population, because they are exactly in the green range of our standard curve. Okay, of course, when we are analyzing numbers that are exactly on standard deviations, this is going to be very simple. But what if we have different numbers? Alright, so that's where the z-score is gonna make sense. Okay, what is the z-score? The z-score is going to use the position in this standard curve, okay, the position in this standard curve, to give us probabilities for all range of data that are not going to be depending on the mean number or the standard deviation number. Okay, it doesn't matter the mean number or the standard deviation number. For all examples, we can convert these probabilities here using the z-score. Okay, so just for our first example, we can say that these two numbers are going to be exactly here, right? Exactly at 1, and it goes up to 1. But what if I ask you to find me numbers in places that are not exactly on the standard deviations? Alright, so what we have to do is to use the z-score table. Okay, first of all, let's understand what is this z-score table. We have numbers, okay, we have numbers in the header. We just change here, numbers in the header, numbers in the first column here, okay, and also we have this huge part of the table in which you have many different numbers. So let's see what we find exactly at +1. We have this number here. I'm gonna come closer. We have this number here, 84. Okay, and what we have exactly at 0? Exactly at 0 we have this number. Okay, so we have 0.50 and 0.841. Okay, so what is 0 exactly? This number 0, okay, this is the main number until the first decimal place, and here are the numbers from 2 decimal places. Okay, so this example here, 0.0 and 0 represents the number 0.0. That's the meaning for it. Okay, doesn't make any sense to write down +0, but it makes sense to write down plus 0.01. Okay, that's why we have this plus here. So for this number here we have 0.0, and for this number here we have the main number is +1. Okay, +1, and +1, let me put here this opaque, and it's going to be 0.0. Okay, 0.0. Alright, so now we have 0.0. Let me rewrite here 0.0, and we have +1. What are the meaning of these numbers? Well, if you come back here to our normal distribution curve, you're gonna find that this number 84, that is exactly at 1, is going to represent this arrow here at 1 standard deviation. Okay, and this at 0 is going to represent exactly the half of data, or exactly on the mean. Okay, so to the left hand side of this curve we're gonna have 50%, to the right hand side we're gonna have 50%. Alright, so what happens if I take this number 0.841 and subtract by 0.50? Okay, let me open my calculator. Let's do it. So 0.50 minus 0.841. How much is that? 0.34. And if I multiply this by 100 to get a percentage, we're gonna find 34.1. Okay, so here for these values we are actually using the position in the standard normal curve to find out probabilities. Alright, so when we are at +1 here and subtract it until 0 here, we just use the proper one, from +1 to 0, this range here, the answer in the calculator is 34.1. That's my percentage. Alright, so we can do this for any number. We don't have to be let's say, we don't have to depend on the standard deviations anymore, because we have a table with all values. So if we want to know, for example, if we want to know a number, the probability to find one of the population that's in between let's say 1.5 here, okay, to 2.3, 1.5 to 2.3. So we have to go to the table. I'm gonna find now the values on the table. Let's say 1.5. 1.5 is here, okay, 1.50, 1.50. So I'm gonna select here is 0.93. And let's see here 2.3. So 2.3 is exactly here. Okay? So to find these probabilities I have to take one number and subtract by the other. So it's going to be 0.98928. I'm using all numbers now. And I'm gonna subtract it by 0.93319. Enter. Okay, the result I have to multiply by 100 to have the answer as a percentage, and now I can see that I have 5.61. Let's round it to 61. Okay, and now we are using the values 2.3 plus 2.3 to plus 1.5. Okay, fine. So this is for the standard normal curve, alright? This is about probabilities. The probabilities are written here in the z-scores table, okay? And here is the position on the standard normal curve, alright? And when we want to use other numbers that is not 0, the mean, and the standard deviation is not 1, because here for z-scores we're going to use 0 for the mean, -1, -2, -3, alright? When we go to the left hand side and when we go to the right hand side, the values is going to be 0 for the mean, 1 for the first deviation, standard deviation, 2 for the second, 3 for the third, alright? It's important to say also that you have in this table here only positive values of z-scores. Okay? So positive values of z-scores are going to always give it to you numbers that are in the right hand side of the normal curve, the standard normal curve. And if you want numbers that are in the left hand side, we need to find negative numbers. For example, minus 1 or minus 1.5 to minus 2.8. So the negative numbers are to the left hand side. So you have to use another table. We have two tables, okay? Two z tables. We have the negative z-score table, in which we have negative numbers, and we have the positive z-scores table, in which we have positive numbers, as you can see here, okay? I'm showing to you here the positive one, but the negative is going to be the same, but with negative numbers. The way that we're gonna do to read the number is going to be the same, okay? It's going to be the same. Just to let you know and practice just before we go for the next topic. Okay, if I want to know what is the z-score for this probability, 0.77.9, 779. This is 77.9%, okay? So we have to read the row and we have to read the column, okay? So this is going to be, let's read it. This is going to be plus 0.7. I will not write down plus, but you know that is positive, 0.7. And the second decimal place, 7 again. Okay? 0.77. That's the way that we're gonna do to write down, to read using the z-score table. Okay? 0.77. Alright. Now when we have this situation, okay? When we have this situation, what's gonna be the probability? What's gonna be the probability to find someone that has the height of 1.83, just to be different, to 1.90 meters? How can we find it? Well, we're gonna use something that we're gonna call the z-score formula. Okay? We're gonna find the z-score by using this formula. So let's go. We have everything that we need. We have the mean, okay? The mean here is 1.77. Standard deviation 0.04. Okay? Score, we have two scores. We have this one and we also have this one. Okay, we have two scores to find. Okay, so let's calculate it. So the z-score is going to be equal to, I'm gonna start with this one, 1.83. 1.83, right? 1.83 minus 1.77. This is going to be divided by standard deviation, 0.04. And the z-score for the first number is going to be equal to, let's take our calculators, 1.83 minus 1.77, enter, divided by 0.04. So the first one is exactly at 1.5. This is going to be the first z-score. Let's call z1. Okay, now let's go for z2. Z2 is like this. Z2 is going to be equal to 1.90 minus 1.77. Get some more space here. 1.90 minus 1.77 okay, divided by the standard deviation. The standard deviation is 0.04. So you're gonna get at the other side, let's use our calculators, simple calculators here, 1.9 minus 1.77 divided by 0.04. Now the z-score is 3.25. Okay, 3.25. So we have z1 and we have z2. How can I find the probability to find people in between 1.83 and 1.90? Let's go. We have the z-scores. So we're gonna use these z-scores to find here at the table. Let's find z1, the red one. Okay, is 1.5. 1.5 is exactly here. We have used this as an example. So let me just surround it with the red mark. This is 1.5. Okay, this is 1.50, right? And the other one is 3.25. So 3.2 is here. Now let's find 0.5. 3.2 and 0.5 is here, is this column here. So it's going to be this one. Okay? Just have to read here. I read this line, 3.2, and also this line over here, which is 5 in the second decimal place. Alright? 3.25. Alright, we have these two numbers, 0.99942 and 0.93319. Let's take our calculators now. 0.99942 minus 0.93319. Okay, I subtracted one by the other, and then at the end we have to multiply the answer by 100. Here is my answer. The probability is 6.623. Okay, probability here 6.623%. Alright, using z-scores, the z-score table, and also using the standard curve, the normal standard curve. Alright, so guys, this is the introduction to solve our exercises. I hope it was useful for you. I will not spend more time here because I want to solve some questions with you. Okay, so I'm gonna start solving a past paper question. Let's go for the next video. Bye.